My name is Professor Avi Loeb, and if you are hearing my voice tonight, it means you've chosen to step into a story that began long before any of us were ready for it. I have spent decades studying the quiet whispers of the cosmos, radiation, debris, signals older than humanity itself. But what happened on the morning of October 24th reminded me that the universe still has ways to make even seasoned scientists stop breathing for a moment. It began, as these things often do, with a tremor of information drifting across the emptiness, a radio absorption line, faint but unmistakably real, captured by South Africa's Meerkat telescope. Hydroxyl molecules, OH radicals, the kind we expect when sunlight tears apart water vapor from an active comet. Except this wasn't any comet we had ever catalogued. It wasn't from here. It wasn't born in our planetary nursery. It wasn't part of our celestial lineage. It came from the dark between the stars, carrying a name that sounded like a designation but felt increasingly like a warning. 3I/ATLAS. I remember leaning toward the console, my pulse quickening when the team confirmed the direction of the signal. It wasn't noise, it wasn't interference, it wasn't atmospheric contamination. It was an object, large, cold, and restless, moving through our solar system with a speed and trajectory that defied the gentle curves typical of frozen wanderers. The temperature estimate landed around -45 Fahrenheit. The diameter at least 3 miles, maybe 6. Enormous. Much larger than Oumuamua. More alive, if alive is a word one can responsibly use about stone and ice slinging through vacuum. Yet the universe does not offer perfect clarity. It offers puzzles, contradictions, challenges. So when that faint OH signature reached our receivers, the scientific community divided like a cell under stress. One side reached immediately for the textbook explanation. This is natural outgassing. Sunlight, sublimation. End of story. The other side hesitated, not because they believed in aliens, but because the rhythms of the universe weren't lining up cleanly. And when the rhythms don't line up, scientists like me pay attention. Only days later, November 9th, optical images sharpened the riddle. The jets erupting from this interstellar traveler stretched 600,000 miles toward the sun and nearly 1.8 million miles away from it. For perspective, imagine something the size of the sun's diameter appearing in your sky, carved not from fire, but from dust and gas ejected by an object smaller than a mountain. These plumes weren't drifting lazily outward like a typical comet's. They were expanding with a violence, a scale, an urgency that made the hair on the back of my neck stand up, and the numbers refused to reconcile. Natural jets do not reach that distance in such a short time. They require months. This thing had been here for weeks. Something didn't add up. When journalists called, especially the ones from tabloids who loved their mysteries hotter than stars, I knew what they'd ask before their microphones turned on. Professor Loeb, do you think it's a craft, a probe, a message? I have grown used to the weight behind such questions. The world wants certainty, even when all I can responsibly offer is possibility. But the truth is that anomalies are the stepping stones to discovery. And anomalies were everywhere in this case. The rapid brightening as it neared perihelion, the mass loss rate that would strip a natural comet down to its bones, the density of the outflows that seemed too cohesive, too intense, too engineered. I'm not saying it is technology. I am saying the natural explanation must earn its place the same way any hypothesis must fight for survival under scrutiny. And at that moment, the natural explanation was sweating. Late that evening, with the lights low in my office and the hum of the computational array filling the space, I pulled up the archival data and ran comparative models. Oumuamua had puzzled us with its acceleration. Borisov had behaved more traditionally, but 3I/ATLAS. This one existed between categories, defying classification the way a word defies translation. It was shedding material with abandon, carving its story across millions of miles. And yet, buried in the jet's violence, there was a pattern of consistency, structure, that made me sit up straighter in my chair. Not a Fibonacci sequence, as some excitable corners of the internet breathlessly claimed. No, nothing that tidy, Nothing that intentional, but something about the geometry of the outflows clung to the back of my mind like a half-remembered dream. As the object slipped near Earth's orbital plane, telescopes across the world sharpened their attention. Observatories linked, networks tightened. You could feel the tension in the global scientific community. It was as if humanity had collectively leaned forward, waiting to see if the cosmos was about to open its mouth and speak again. Even NASA repositioned instruments, prepping for the December 19th approach, the moment we hoped Hubble and Webb would unveil the true composition, velocity refinements, and total mass of the jets. Meanwhile, Juno quietly added a new line to its mission timeline, March 16th, 2026. A close pass near Jupiter, where its dipole antenna would listen for low-frequency signals that might whisper secrets only deep space can carry. It was a rare alignment. Telescopes on Earth, telescopes in orbit, a spacecraft drifting near a gas giant, all converging on one interstellar stranger. Around the same time, another thread entered the conversation. The trajectory of 3I/ATLAS aligned within 9 degrees of the direction from which the 1977 WOW signal arrived. Coincidence, perhaps. Coincident enough to ignite headlines, certainly, and yet, even for someone as cautious as I am, the symmetry felt eerie, not convincing, but compelling, as if the universe were nudging us, softly, ambiguously, reminding us that it is older than our doubts and bolder than our fears. By the time the first wave of public fascination swelled across social media, the narrative was already fracturing into two worlds. In the scientific world, we dissected data and sharpened equations, trying to wrestle clarity from the chaos. In the public world, mystery bloomed like wildfire. Clickbait headlines calling it an invader, an interstellar visitor, a cosmic trespasser racing through our solar system. And somewhere between those two worlds I stood, carrying the burden and privilege of interpretation. I remember walking home late that night, the November air sharp against my face, thinking about how humans respond to mystery. Some cling to certainty, gripping it so tightly the truth slips away unnoticed. Others hunger for wonder, for a doorway into the unknown. And then there are those like me, who stand on the boundary, refusing to let fear or fantasy dictate the narrative, because the universe is not impressed by our categories. It is a storyteller, and it tells its stories through fragments, signals, shadows, jets of material firing across millions of miles. It tells its stories through the anomalies we cannot ignore. And 3I/ATLAS was an anomaly we could no longer look away from. In the days that followed, the debate around 3I/ATLAS deepened like a fracture in the crust of the scientific world. I could feel the tension in every interview I gave, in every message from colleagues who usually spoke with the confidence of people standing on bedrock. Suddenly, the ground beneath all of us felt less certain. The natural comet camp doubled down, repeating the same explanations with increasing insistence, as though volume alone might make the universe agree. Water sublimates. OH radicals form. Jets erupt. Nothing unusual here. Move along. But data is not persuaded by repetition, and the numbers were not cooperating. Each new observation added a layer of strangeness, a new angle that made the natural explanation wobble. The jets weren't simply large, they were colossal, expanding with velocities that made seasoned astronomers mutter under their breath. The brightness curve spiked too fast, rising like a pulse under stress. And the mass loss rates, when calculated honestly, suggested the object should have shed a significant fraction of itself already. Yet the shape, the profile, the activity were still intact. It was like watching a candle burn without shrinking, flame roaring as if fed by an invisible reservoir. I tried to explain it in lectures, in emails, in public discussions, but every explanation ended the same way. We need more data. I spent one long night at the observatory, pacing between the terminals as new frames came in. The object glimmered faintly on the screen, an ember against the vast black sea. It was absurd, almost comical, that something so small could command so much global attention. And yet there it was, gliding silently at unimaginable speed, shedding material like a comet, but not behaving like one. At times, I felt as if it were performing for us, an actor on a cosmic stage, revealing just enough to intrigue, never enough to settle the argument. Of course, that is superstition dressed as poetry. But even scientists are allowed unguarded thoughts, especially at 3 in the morning when the room is filled with the hum of machines and the universe feels impossibly close. When dawn approached, I stepped outside, letting the cold morning air clear my mind. The sky was a deep purple, fading toward the blue of sunrise, and for a moment I imagined the object streaking across that canvas like a brushstroke. Somewhere out there, beyond the horizon, it moved with determination, undaunted, unaffected by the swirl of human speculation. And as I breathed in the crisp air, I realized something unsettling. We were not studying it from a place of control. We were studying it from a place of vulnerability. The object wasn't visiting us. We were the ones standing still as it carved its arc through our cosmic neighborhood. News outlets seized that vulnerability like wolves catching a scent. Headlines flared across screens. Interstellar visitor sends mysterious signal. Jets larger than the sun, scientists baffled. Alien probe or cosmic anomaly? Some outlets invoked my name repeatedly, twisting careful scientific language into bolder claims than I would ever make. Professor suggests technological origin. Loeb hints at engineered jets. It is the burden of being open-minded. People often hear what they want, not what you say. Still, I wasn't angry. Public curiosity is not a threat. It's a reminder that humans are wired to seek meaning in the unknown. The danger lies in dismissing anomalies too quickly. That is when science becomes dogma. So I stayed the course, answering questions with the same disciplined uncertainty. We don't know yet. The natural explanation is possible, but the anomalies deserve honest attention. One of the strangest developments came from amateur radio enthusiasts who swore they picked up faint whispers near the frequency of the O-line. The claims spread online like sparks in dry grass, but none were reproducible. And yet the excitement served a purpose. It reminded the world that discovery is not the private property of elite institutions. The universe is democratic with its mysteries. Anyone with curiosity can participate. Meanwhile, the December 19th approach loomed larger each day. Scientists booked observatory slots months in advance. NASA prepared tight protocols for data transmission, ensuring redundancy in case anything unexpected occurred. Conversations in research groups grew quieter, more charged. Even those who dismissed the sensationalism could not ignore that this was a once-in-a-generation opportunity. Interstellar objects do not knock on our door often. They slip through the night without warning, like brief visitors from a world we may never see. Then, without fanfare, a new anomaly surfaced. When researchers plotted the geometry of the jets more precisely, they noticed a subtle asymmetry, not enough to declare intention, but enough to raise eyebrows. Jets from natural comets scatter broadly, snowstorm-like, governed by chaotic venting, but 3I/ATLAS showed signs of structure, regions of concentrated outflow that maintained orientation longer than expected. I stared at the diagrams, the curves, the vectors. My mind offered interpretations before my caution could stop them, but I swallowed those thoughts. Let the data speak. Let time reveal what adrenaline obscures. Days later, my inbox filled with questions about another coincidence, the WOW signal alignment. 9 degrees, not perfect but suggestive, enough to inspire a narrative, enough to build a bridge between 1977 and now, enough for tabloids to print it in bold letters, flanked by graphics of neon green aliens. But beneath the sensationalism, a quieter truth whispered, the universe is not random. Patterns can emerge even where causation does not exist, and recognizing coincidences is not the same as confirming them. Still, part of me, perhaps the part that first fell in love with astronomy as a child, felt a shiver. What if the cosmos has been nudging us for decades with whispers too soft for us to recognize? That afternoon, I met with a group of graduate students. their eyes wide with the same mixture of skepticism and wonder that had fueled my career. They asked difficult questions. They challenged assumptions. They pushed back against complacency. And as I listened to them debate, I felt something shift in me, a realization that the mystery of 3I/ATLAS wasn't merely scientific, it was cultural, emotional, philosophical. Because whenever humanity encounters the unknown, we reveal more about ourselves than about the thing we study. The students left, but their questions remained. Could a natural comet produce such colossal jets so quickly? Could outgassing alone explain the brightness? Could mere ice mimic intentional propulsion? Or were we witnessing the limits of our understanding, the edge of a map we had drawn too confidently? As evening fell and shadows stretched across my office, I looked again at the trajectory of 3I/ATLAS. It sliced through our solar system like a blade, indifferent to the uproar it caused. And somewhere deep in my mind, a quiet thought rose. Perhaps the universe was giving us a test, not of intelligence, but of humility, because the greatest discoveries often begin with the courage to say three deceptively simple words: we don't know. As December 19th approached, the world seemed to hold its breath. It wasn't just astronomers anymore. It was everyone. Students, journalists, hobbyists, skeptics, dreamers, all waiting for the curtain to lift on a cosmic stage none of us had built, but all of us were watching. I felt the anticipation each morning when I checked the incoming data, each night when I looked up at the sky and imagined a 3 to 6 mile object tearing silently across the solar winds. No propulsion noise, no lights, no messages, only the raw, impossible spectacle of those titanic jets burning across a distance larger than the sun itself. On the day of closest approach, Hubble and Webb synchronized like twin scalpel blades slicing into the mystery. Their observations arrived in bursts, spectral lines, velocity refinements, mass estimates rendered in colors and curves only astronomers could love. And as the numbers took shape, I could feel a familiar tension coil within me, hope on one side, caution on the other, warring like two tides colliding in darkness. The first results suggested a composition broadly consistent with volatile-rich bodies: water, carbon-bearing molecules, dust, the kind of ingredients that forge comets. But the jets defied the idea of ordinary sublimation. Their mass was far too large, far too fast, far too luminous. Even after all the debates and interviews and late nights, I felt a shock run through me, because if this was a natural comet, it was unlike any we had ever recorded. And if it wasn't natural, then the universe had just nudged us toward a truth we were not prepared to articulate. I spent hours reviewing the optical data. The asymmetry remained stable, persistent, unwilling to fade into randomness. In the natural world, pattern is a product of physics. In the engineered world, pattern is a signature, but physics alone, at least the physics we understood, struggled to justify what we were seeing. I placed my hands flat on the desk, feeling my own pulse against the cool surface, and said softly to myself, "We need more time." Across the world, reactions split exactly as I expected. Some headlines declared triumph. Mystery object revealed as natural comet. Others fueled the fire. Jets too powerful to be natural, scientists stunned. And somewhere between those extremes the truth wavered, delicate, unresolved, resisting simplification. That was the part the tabloids never understood. Mystery isn't an inconvenience, it's a signal that the universe is still speaking. As evening broke across the observatories, I stood outside beneath a crisp winter sky. The object was invisible to the naked eye, but I felt its presence like a distant drumbeat. A visitor from another star system had passed near Earth, leaving behind a trail of dust, jets, questions, and quiet astonishment. It did not stop to communicate. It did not slow down. It did not break apart. It passed through our cosmic neighborhood with indifference, as though fulfilling a journey it began long before humans learned to whisper stories into firelight. And in that moment, I understood something essential. The significance of 3I/ATLAS wasn't in the answer. It was in the interruption, the way it disrupted our comfort, challenged our assumptions, forced us to confront how much of the universe remains unseen. When I returned to my office, the last of the data from the approach had arrived. I opened it with steady hands, scanning the values, the curves, the noise, and though I found no secret message, no engineered signal, no incontrovertible proof of technology, neither did I find a satisfying, natural explanation. It was like standing at the edge of a forest and seeing only the shadow of something large moving between the trees, real, undeniable, yet never fully revealed. Humanity will study 3 I/ATLAS for years. Juno will listen again in 2026. Ground observatories will dissect every micron of dust it shed. Perhaps one day we will understand why its jets stretched across millions of miles with such impossible urgency. Or perhaps the truth will stay just beyond reach, a whisper carried away by the darkness between stars. Before leaving for the night, I glanced once more at the trajectory map pinned to my wall. A thin line traced its path through our solar system, clean, graceful, unstoppable. It reminded me of a single stroke of ink across paper, a signature from an author we cannot see. I don't know whether 3 I/ATLAS was entirely natural or subtly engineered. I don't know why its jets defied our expectations. I don't know why its path aligned eerily close to the direction of the WOW signal. But I do know this: mystery is the oxygen of discovery, and the universe, in its quiet, indifferent generosity, has just given us another breath. As I turned off the lights and stepped into the cold night, I whispered the truth that every scientist must learn to live with, not as an admission of defeat, but as a vow of curiosity that binds us to the stars. We still don't know, and that is exactly why we must keep looking.